You know, one of the main skills that you will have to develop in this day and age is the ability to distinguish between what is real and what is bullshit. Every day you are bombarded by appeals, by solicitations. Somebody or something is pitching you to act or to decide on a particular course of action. And the most convincing of those appellants or appealers are those who actually use good, rational argumentation. And so those are the ones that you really need to be extra cautious of. You see, the snake oil salesman, the guy that tells you a nonsense story and you can see through it, he's not really dangerous to you. It's the scientist, it's the medical expert, it's the professional lobbyist that you need to be afraid of. Because these are the operatives that are successful, that are getting you to decide what they want you to do. But obviously there's a lot of bullshit being flung at you, and you need to learn the skill of how to counter this. Now let me show you one. There's a lot of ways that you can counter bullshit, but I'm going to show you one of the important tricks that they use. And it's unfortunately grounded in a bit of mathematics, but I think I can make it easy for you. Now, when I studied statistics, right, many years ago, I'm going to try to recall a little bit in my own way what I've learned. And let me share with you this particular way in which you get bullshitted. Like if you consider this fact of nature, let me show you something here. This fact of reality. You get what we call the Central Limit Theorem. Let me just write it here. And you can go and Google it. And this theorem says that if you have a population or a sample or a group of items that you are sampling, can we say the height of men, then you will have different measurements, right? You will have x1, x2, x3, all the way to xn, all the men that you have. Let's say 10,000, let's say there's 3.5 billion men in the world, and you measure the height of 3.5 billion. So that is all the men in the world, the heights. All right? Are you with me? So you have the heights of men, x1, x2, x3, up to xn, 3.5 billion men in the world. Now you want to find out what is the average height of men in the world. So you need to add up all the heights up to 3.5 billion and divide it by 3.5 billion. Is it not so? So you might come to a figure of, let's say, 1.7 meters. Right? So you might come to a height of 1.7 meters is the average height. If you take all the Chinese people in the world and all the Central African men and all the Europeans and all the South American men, and you add them all up, you get to 1.7 meters. But here comes the catch. In terms of the Central Limit Theorem, you cannot normally add up all the heights of all the men in the world. It's not practical. Men are being born all the time. Men are dying all the time. So how are you ever going to measure all the grown men in the world? So what they do is you sample 1,000 men, and then you work from that 1,000. So you will take a random sample, which is a good representation of all the men, over 10,000 or 100,000 men, doable, and you will get to the real average. Now here comes the catch, because I need to introduce it. I can't unfortunately do it any quicker than this. So now you have a smaller sample. You have x1, x2, up to xn. Now the small sample, right? Not the big N, the small sample. This is your sample. And now you're going to get an average of that, which will be small x, and that is your average. So let's say the real average is 1.7 x. The big average is equal to 1.7 meters. And your average of the small sample, which you took to measure the height of men, is maybe 1.71 meter. Slightly different. But we know that if you sample a small group, it will generally, the average will be kind of, if you do your sampling properly, it will reflect the real average of the real population. Are you still with me? I hope you are. But now comes the catch. In terms of the central limit theorem, the central limit theorem says that you're going to measure a whole lot of averages. All right? Can we use now the word mu for those averages? You have mu1, you take one sample, then you take mu2, another sample, then you take mu3 up to mu p. If you consider all those samples of averages, then those samples of averages, those samples of all the averages will actually be, we use the term normally distributed. Let me just take myself out of the picture here. So those samples, all the mu's, mu1 to mu p, will all be distributed around the actual average. Now I'm coming to the key point. If you didn't understand what I said, you can replay till you get it. But this is very important because I'm trying to show you how you get bullshitted. So now comes what we call the central limit theorem. What that theorem says is that in any population, the mean, the average, is distributed normally around the actual mean of that population. But that there is a likelihood that, or not, there's a small likelihood that you could get means being produced by your sample which is up to 1 or 2 or 3 standard deviations away from the actual mean. So right, let me take the complicatedness away from you. What it means is that most of the time when you sample the heights of men, most of the time you will get a good answer. You will get 1.7 meters, right? But if you keep on sampling, and if you keep on sampling, and if you keep on sampling, you will start getting fringe results. If you keep on sampling, you will even get the average height of men being 1.9 meters. There's a chance that you can get, if you keep on sampling, you will get fringe results. So you sample normally, you get good results, you get 1.7 meters, the average height of men. But if you keep on sampling, you will get fringe results. Are you with me there? Do you get what that is all about? I hope I've got you with me, because here comes the key point of this little video now. Let me come to the key point. What we said was that we have a sample of a bigger population, and that sample produces generally a good result. But if you sample continuously and you carry on and you carry on and you carry on and you do 20, 30, 40 samples, you're going to start, it will deliver some fringe results, right? Which is not even close to the actual mean. Now, let me take it to the next level. You see, the trick now is that how can this be abused? When you sample, and you sample until you get the result you want. Let's say I want to get to the result that men's average length is 1.9 meters. But as every time I sample, it comes out 1.7, 1.71 meters, 1.79, 1.72 meters, 1.69 meters. You know, it all the time it just hits the 1.7 or slightly off. But the moment I keep on going and keep on going, eventually, in terms of the central limit theorem, I will hit an average of 1.9 meters. I will be sampling in such a way that by chance just drew in all the bigger men, and I will then hit on a 1.9 meters. So if I then use that sample or that particular study, then I can actually come to people and say, look, I've done a scientific study of 2,000 men and the average height is 1.9 meters. Now, this is exactly the bullshit that the pharmaceutical companies implement. They will go and trial a new medication, and they will try it on 10,000 people. And what they will find is that it doesn't make a noticeable difference. It does not create a noticeable health. It doesn't have a noticeable benefit. But what they will then do is they will discard that study and go to the next and do a trial all over again. Scientifically. They will do it scientifically. Discard all the data, the whole sample, start a new sample and test the medication or this whatever they want to try out on a new population, on a new sample. And they will get the outcome, and it might not work, and they will discard it again because it shows that the medication does not have a noticeable or what we call a significant health benefit. And so they will continue and continue and continue until one day, after maybe 7 or 8 studies, they get the result they want. And then they destroy all the other studies, all those other studies, and they use the final one that gave them the result. I'm not making this up, people. Let me show you this article. Let me show you this article where it says, this is in Scientific American, how farmer-funded research cherry picks positive results. Look at this. I'm going to show you. This is how you get bullshitted, my dear family members and friends. Excerpt from how drug companies mislead doctors and harm patients. Right? Before we are going, we need to establish one thing. Industry-funded trials are more likely to produce. Right? That's good. They need to that's a good point there. More likely to produce a positive flattering result than independently funded trials. This is our core premise, and you're about to read a very short. So I'm not going to go through the paper, but what it says is basically that the trick that is used by big pharma companies is the central limit theorem. Is if you continue to run trials scientifically, then you will eventually get to the result you want. It's almost like, you know what, I take a video of me dunking a basketball, but I record every time I dunk the ball, and I miss every time. And then on the 20th attempt, I actually dunk the ball. The ball goes into the basket. But what I do is when I show it to people, and I actually delete all the 19 times that I missed the basket, and I show this amazing shot from 30 meters away where I actually dunk the basketball. And obviously the people are going to say, yo, Anwar is great at dunking the basketball. Look at him, he's a star. But I have deleted the 19 times that I've tried unsuccessfully, and this is how you get bullshitted, my dear friends and family. And they use mathematical and statistical facts, and you have to be careful. You know, I'm just going to throw in a last one because we have a nice 15-minute video. You know, if I tell you that 30 people a year die of lightning strikes, 30 people a year in South Africa die of lightning strikes. So what we're going to do is I can highlight those 30 people. I can tell you those 30 people's families and how they lost their income and how every one of those 30 people had a precious life, and how, you know, you can go and create 30 sad stories, and you can use that sad exaggeration of the 30 deaths to create a new law that you from now on want every human being to wear a wooden hat, a hat made of wood, and citizens are compelled to pay 50 rand to wear that wood whenever they're outside, to prevent them from dying of a lightning strike. But obviously what we are seeing is an exaggeration of a problem and a solution that is much more harsh and cumbersome than the problem itself. And you know what? I'm telling you these things so that you can realize how you are being lied to, how you are being deceived, and the amazing tricks that are being used in the name of science. And you know what? When you study statistics and when you study them, you have to really be immersed in these things to realize how you are being lied to. You know what? Let this be a wake-up call for you. Please think twice before you are drawn in to believe people's bullshit that they tell you.